Okay, so we're going over problems from 7.2. What is molarity? Practice with using molarity to find moles, liters, etc. Okay, so first problem is the most basic molarity problem. Remember that molarity is equal to the number of moles of your solute divided by liters of solution. Okay, we use capital M for molarity, but the units are actually moles per liter. These two things, capital M and moles per liter, mean the exact same thing. So let's look at our problem. It says, what is the molarity of a solution produced by dissolving 4 moles of sugar in 2 liters of water? Okay, so we're looking for molarity. That's our unknown. So we take our moles of solute divided by our liters of solution. So the molarity is equal to 4 moles divided by 2 liters. And you get 2 moles per liter, which we write as a capital M. That is a 2 molar solution. For every 1 mole you have 2 moles of, for every 1 liter you have 2 moles of solute. Okay. Let's look at another problem. Now I'm on number 5, how we can use molarity to find number of moles. This problem asks, how many moles of NaCl are in 2 liters of a 3 molar solution? Okay, so our knowns are 2 liters, and just for the sake of seeing it easier, I'm going to write it as 3 moles per liter. And I'm going to show you 2 options of solving it. Option 1 is to just set it up in the equation. Okay, the equation is molarity equals moles over liters. The molarity is 3 equals number of moles, which we don't know, I'm going to call it X, divided by 2 liters. To get the number of moles by itself, we times each side by 2. Okay, cancels out over here, and you get X equals, okay, remember M is moles over liter, liters on top, liters on bottom, so you get 6 moles. Okay, that's one way to solve it. It might make more sense to you to always do it that way. Option 2 is to use dimensional analysis. Okay, dimensional analysis is where you look at the units you're given and figure out how to set it up to get the units that you want, okay, which is moles. So these 2 numbers, I'm going to start with the one that doesn't have something on bottom of it, 2 liters. I want moles, so I'm going to put the 3 moles per 1 liter. Okay, that's this. Okay, this equals 3 moles per 1 liter. Okay, mole per liter, moles per 1 liter. Liter and liter cancel out. You have 2 times 3, which is 6 moles. Okay, you'll get the same answer either way. It's just whichever method makes more sense to you. I prefer dimensional analysis. That makes more sense to me. Okay, let's look at another problem. Okay, very similar problem, only instead of looking for moles, we're looking for liters. The problem says how many liters of a 2 molar NaCl solution contains 4 moles of NaCl. Okay, so I have a solution of salt water. If I want just the salt, how many liters would I need to have 4 moles? you might be able to figure it out intuitively, but if not, our knowns are 4 moles and 2 molar or 2 moles per liter. Okay, same thing. Again, we could do option 1 and go 2 moles per liter equals 4 moles over x, which is our number of liters. Okay, you would cross multiply, solve it out, but I think it's easier just to do dimensional analysis. Okay, so I'm going to start with my 4 moles. Now I have this 2 moles per liter. I'm going to put the 2 moles on the bottom so that it cancels out. And I'm left with liters, which is the units that I want. Mole and mole cancel out. 4 times 1 divided by 2 gives me 2 liters. And that's my answer. If I wanted 4 moles of NaCl, I would need 2 liters of a 2 molar solution. Okay, let's do one more problem that is a little bit harder. When these problems get hard is when you have grams involved in it, okay? But most of the time, we use grams. We don't have a direct way of measuring moles. So let's go ahead and figure out our knowns, okay? If I want to make 4 liters of a 2 molar solution of salt water, how much NaCl in grams would I need to weigh out? Okay? So, if I'm going for grams and I have moles in moles per liter, I'm going to need the molar mass. Okay? So, no matter what, I'm going to need to find the molar mass of NaCl. Okay? NaCl, there's one of each. Na has a mass of 22.99, chlorine 35.45. Okay, add them together, you get 58.44 grams per mole. Okay, that is something that I know I'm going to need, so I'm just going to put it in a box. Okay, and now I'm going to show you both options for how to solve this problem. Okay. Option 1 is to do it in steps. Okay? If you do it in steps, step 1 is convert. For this one, the only thing I can do is I can figure out how many moles I need. So find number of moles. Okay? So I know I have 4 liters. Okay? Of a 2 mole per liter solution. I could have solved this out using the other way, but it's just figuring out moles. I need 8 moles. Okay? And then I can do step 2, which is convert to grams. Okay? So I would do 8 moles times 58.44 grams per 1 mole. Okay, mole and mole cancel out. I have 8 times 58.44, which gives me 467.52 grams. Okay. This is doing it out in 2 steps. I could have also done it all out in 1 step. Okay, and I'll show you how that works. Okay. Option 2 is to use dimensional analysis. Okay. So start with what I want. Okay. I want 4 liters And I'm trying to figure out how to get that to grams. Well, molarity relates moles and liters. Okay, moles is a step closer to grams. So I could go 2 moles over 1 liter. Okay? Then liter and liter cancel out. I'm left with moles. But I want grams. So then I would use the molar mass, grams per 1 mole. Okay? So that mole and mole cancel out. I multiply those 3 numbers together, divide by 1 and 1, which is basically just dividing by 0, and you can see that it is the same. 4 times 2 equals 8 times 58.44, and you get the exact same thing. 467.52 grams. Okay. So this right here, again, was the molarity, and this is the molar mass. And as long as you do it, set it up so that the units work out, it doesn't really matter what order you put any of these things in. It will still work out right. I just always think it's easiest to start with the liters, or whatever doesn't have something down here. Okay? And that's how we're going to be using molarity.